So I'm Michael Ambrose. I'm the technical lead for the Concrete Road Centre of Excellence, and this is to talk to you a bit about the work we're doing and also a bit about the Concrete Roads Legacy Programme. I work in the Operations Directorate, so I work closely with my SES colleagues, taking some of the research and things that they have developed, if you like, and then putting them into practical use in schemes around the network. So our priorities at the front end are always about safety, customers, delivery, and the environment. So when we're ever looking at any of the things we actually look at for research or innovation or implementation, those are our four key factors we look at in terms of that. The Concrete Roads Programme as a whole is 4% of the network currently. That's likely to get a bit bigger because we've done some new surveys which show us where some additional concrete is that wasn't included in the RIS2, so that's the Road Investment Strategy period.
Michael, sorry to bother. Could you make it full screen just so it's visible?
I've tried to, I just don't quite know how to do that.
I'm wondering if you press present.
Okay, try that.
That might.
Is that better?
Yeah, perfect. Thank you.
Okay. So this gives you an idea where all the concrete roads currently are in the country. There are other concrete roads, and our legacy pavement is the type of pavement you see, which is exposed concrete or with a thin 50mm asphalt overlay. All of the legacy pavement is at least 40 years old, so it's at end of life. And with the oldest section we've got on the network at the moment being 60 years old, and all of it is over its original design load. So typically when we design for around about 100 million axles over its lifetime. A lot of this is now in the region of 150 to 160 million axles. So it's actually performed extremely well. It's the strategy, if you like, that I come up with is how to maintain that going forward until such time as we can reconstruct it. So that kind of gives you a brief look at where on the network we have the various lengths of road. The Centre of Excellence itself is split into various areas. At the moment, it's just myself and Clara, although I've got somebody new joining me in December. At the moment, we're looking at things like materials, which Peru will probably touch on more when he talks about repairs. The legacy side is looking at the benefits we have of creating such a programme on that basis. We also have an environmental side, which is looking at how we look after the environment, do things better with carbon, and also any other benefits we can achieve. One of the biggest ones we have with concrete roads is noise. So we're constantly looking at how can we reduce noise down to help our customers both in the car and in the environment live alongside a concrete road. One of the other ones we also have is non-destructive testing, or testing as a whole. Previously, prior to the program, we used to go out and core holes all over the concrete to find out what it was, what we were doing with it. That damages the concrete slab. So effectively, you're taking roughly a year or 2 years off the expected life of the concrete, if you like, just by coring it, because you create weaknesses in it. So one of the things we set out to do at the beginning of the journey in 2018, 19, 2020 was to actually find ways to have a look at things non-destructively. So when we do cores, we do it for a specific purpose and specific reason. And the final one is asset management. How do we manage this asset going forward? Where do we have critical risks, if you like? And those are both in the strategic long term in terms of obtaining enough money to reconstruct, but also the day-to-day issues. When do I think the concrete is going to blow up to an extent where it becomes unsafe to travel on the road? So we'll be talking to you more about that as we go through. So we're talking on the environment. One of the things we did here was basically look at things like reduction in carbon. So what we've done is we've created a carbon model now that runs through the stages of construction. So in optioneering, when we first start, we put together what we think will be the carbon total. And that's based in optioneering on looking at the surveys, looking at the initial design factors around a scheme. In prelim and detailed design, we're hoping the designer will then further drive down that total. And then the constructor comes along and looks at what he can do to drive down the total further. One of the things we wanted to do with our model, though, was create a conversation throughout a scheme, rather than just collect the carbon figures at the end, to say what is it we could do that will actually reduce the carbon further. So a good example of that is a lot of our nighttime closures have huge diversions to them in the East region, so 40, 50 miles diversion. So that's a lot of cars to send down and lorries down another route, if you like, when they could have originally done the original section in 5 miles. So one of the things we're looking at is, do we need to close at night time? Would intensive weekend closures or even contraflow be better for some of our schemes to save the carbon? Most of the carbon we look at is actually generated by the diversion routes and the length of time of possession on the network. So we're looking at that particularly. Whereas I can get 1 or 2% by changing materials, I can get 20 to 30% reduction just by looking at the operation repair wise. Noise-wise, concrete roads are always perceived to be very noisy, and yet some of the noise work we've done last year and this year has suggested that we can actually make concrete quieter than asphalt. We just need to use the right techniques to do that. So what does that mean? That means typically for you as a car user, you won't even notice you're traveling on concrete until you can see the color of the pavement. It also means that we can pull in the noise envelope for a road from 600 meters back towards 400 meters. So that means that the noise from the road becomes the less significant noise at around about 400 meters onwards in terms of disturbing people. Concrete itself, there's lots of studies in the States that suggest that concrete as a running surface actually reduces pollution. It's an extremely good running surface for that. So one of the things we need to think about doing when we replace or repair the concrete is how to keep that surface optimized, if you like, to reduce the actual use of petrol while people come over it. Value for money, we've been looking at things like when we do repairs, how long do we want the road to last for before we reconstruct it? So for instance, there's no point in pumping millions of pounds into the actual road repair if you only want it to last 5 years. And so at the moment, we've been looking at a range of techniques and monetary factors to look at in terms of how much do we spend, and is it worthwhile spending that amount? And will that give us the period of time we want to look forward? So typically I'm looking forward 5, 10 or 15 years before we either have to re-intervene or we go for reconstruction. To help us with all of this in terms of asset management, part of our planning has involved creating new models, which will start to show people early next year. This is new deterioration models about how long we think end-of-life concrete lasts. Prior to our work, nobody had internationally done any work at all on what it is to keep end-of-life concrete going, in terms of modeling it, in terms of how far can you push it before it fails. So we've now got a model, deterioration-wise, which fits into the states of concrete. That basically kind of gives us an investment strategy to look at when we're working with the concrete pavements moving forward. Recycling. We've had a long, hard look at how we recycle. So at the moment, all the reconstruction schemes in the East take 100% of the existing concrete pavement and put it back down further in the formation of the new roads. So that means we've got 100% carbon capture from the original road locked up, if you like, in the new pavement. We've also looked at what can we do, for instance, with crushed concrete. So when we take it up, are there other things we could use it for, such as central reservation barriers, new drainage, just even new paving steps to the side of the road for access purposes. So we've looked at a range of things there. The most effective use for us in terms of both carbon and cost is actually just to put it back in as the baseline in the pavement. We've also looked around carbon assessment, and we're still working on that to try and get the best output from that on that basis. One of the other strategy drivers for us is actually where aggregates are in the UK. So this gives you an idea of where our concrete exists or where aggregates exist in the UK. If you notice, for instance, the East region is particularly bare of aggregates, which we use in concrete or in any form of construction. And one of the biggest challenges facing highways in national highways as we move forward is actually the fact that HS2 will take up to 80 to 90% of the current quarry output in the UK when it gets fully online. And we're already starting to see scarcity and shortages. So John Cole, who was with the business, is now left, but one of the biggest things he said we need to be thinking about is using the biggest quarry we've got, which is actually our own network. So on that kind of basis, we've been looking at how we recycle and reuse the various aggregates back in the business. Materials-wise, we've done a range of different things. We've looked at inlay crack repair, and I'll leave this to Peru to cover more off about repairs and things. Partial depth repairs, full depth repair materials, thin bond materials. And we've even looked at precast slabs, very heavily used in the States, but not really done over here. So we've actually designed our own slab for the network. And the idea about this is rather than just cast 2 slabs per night per team, we think we can probably get about 4 to 6, which is a huge step forward in production. It also means that we've got a faster way and less weather dependent way of actually repairing our roads as we need to. I've got a depot up in Wymondham in Norfolk, where we have a lot of these trial patches in and bits and pieces in there. And I'm more than welcome to organise a visit for anybody who'd like to come up at some stage. We've done trials up there with the materials, so we've actually laid things side by side. And part of the reason for doing that is this depot is a heavy used maintenance depot. So we have all sorts of lorries doing all sorts of things across the surface there. And what we're keen to see is what stands up to wear and tear over a number of years going forward and how it performs. With non-destructive testing, one of the things we found is that we weren't very good at looking at what we do and what gives us the best results back. So we did a number of studies in Essex and Suffolk, which I'll show you in a minute, where we looked at testing the same 1 kilometre strip of concrete over and over again with different devices to see what's the most effective. So we've used 2D and 3D GPR, both walked and driven. We've used a falling weight deflectometer, which looks at the transfer of weight between slabs, and also an enhanced falling weight deflectometer, which is driven to see what we could see there. We've also done walk visual surveys. We've also used LiDAR with both Leica and Trimble-driven devices to get an idea about which was the best in terms of giving us the information about the road. I'll explain more to you later on about how that's developed the digital road for us. And we've also looked at ultrasound. So one of the things we're keen to do is try and understand our pavements when they start to fail as to what is going on and how we can actually have a look at that in detail. So just a brief bit about the 2 site things we used. One was Mount Bessing Bypass, which is a deep asphalt overlay over concrete to see what we could see there. Typically, we'd spend a lot of time coring this pavement if we wanted to investigate it. And one of the interesting things that non-destructive testing showed us was, in fact, the pavement has now become crack and seat. So our original asset knowledge has changed since we've done the survey as a result of this. We have found that the 3D or any driven survey is actually just as applicable as any walk survey now, and in fact probably better in terms of repeatability of results. And the other one we did was looking at the exposed trial site around Chelmsford Bypass, and again we found things that by looking at exposed concrete, that in fact we could get quite a lot from driven surveys, and even where we need to do intrusive surveys, we can do those more effectively by looking at the sections we need to go to. So the legacy, one of the things that came out of us first looking at the Concrete Roads programme was to look at what happens in the future. Our programme at the moment is around about 35 to 45 years to take all the existing concrete off the network. So that means we're looking ahead to see what kind of skills we need for the future in terms of maintaining the existing asset and how we go about demolishing it and creating new pavements and road from that. So to give you an idea, 60% of the people who have constructed concrete pavements will leave the business in the next 10 years. That's out of the construction business as a whole in the UK. So that means we've got a huge gap to fill with people like yourselves stepping up, coming forward and actually helping us build the new roads of the future and maintain the existing ones. So what have we done to that end? We've created a new concrete pavement maintenance manual with all the best practices around concrete pavements, how to assess them, what are defects, how we go about best practice in terms of reconstructing or repair work. The last manual prior to this one was written 31 years ago. So as you can imagine, there was a real need to update that to make it credible with the current standards we have, and also to make it relevant, if you like, the current maintenance techniques. We also have 8 videos to go with this around our approach to the environment, non-destructive testing and materials. Again, we're quite happy to share those with you if you'd like to have a look at those. We've also set up a postgraduate diploma in concrete pavement maintenance manual. So this is for undergraduates to postgraduates, sorry, to come through and to spend 2 years part-time picking up the knowledge around what it is to repair the concrete pavement in detail. And then that leads on to a route as incorporated engineers with the Concrete Institute of Technology. And the other thing then we're looking to do is bring up people through a career scale, if you like. So that's training apprentices right from school at 18, right through to people at 25, 30, who perhaps have gone a practical route in the industry and now want to come up and, if you like, be the engineers of the future. So we're looking to create, if you like, streams, if you like, of education and learning career progression routes all the way through the business on that basis. So one of the big things we've actually managed to do in the last period of time is the end-to-end digital. And this is probably one of the biggest things out of the 67 projects we've worked on in the last 2 years in terms of actually producing something that probably is very innovative and revolutionise the digital road as we move forward. So what we found with concrete is we could capture using digital vehicles to capture using LiDAR, the imagery and the point cloud that we need to look at how we identify defects on the network. We then linked in with another company to look at developing an automated defect identification, so that AI runs over the pavement and looks at where the cracks and defects are, but it also suggests where the repair are. And what we're looking to do in the next year is actually come up with an automated repair design to go with that. At the moment, it's very manual, but as a whole, it allows us to look very quickly. Typically, prior to this, we would literally spend days looking at video and marking on a pavement sheet where we wanted the repairs to be done, where the defects were, etc. So this alone allows us to speed up considerably the design and the initial optioneering process, if you like, in terms of what we're thinking about doing. We can then export all the defects we've seen that we want to repair in and out of the portal. Some of the designers like it to work on their own processes. Other people quite happy designing the portal, so we can do the initial designs there, or take them out and use shape files, CAD files to work on it further. We can also update that by taking it to the field. So once we've done the design, we can push that back into the portal, which means when we go to the field, we can either update it where we see the defect and the repair that's suggested for that defect has got larger, because it can often be up to a year to 18 months between the initial capture and the subsequent time on site. So we can update the size of the repair, the type of repair very quickly. We can also do augmented reality, so we can walk down a road with you and show you where all the repairs are to 2 centimetre accuracy. And you're saying to me, well, why is that important? Typically on a scheme, it would take us up to 3 days to mark out where all the repairs are on a 5 kilometre section, whereas using the new technology, we can actually do that in a single shift and know exactly what we're repairing on that basis. And then as we do the repairs, we can capture all that information. So we can recapture the product, the repair type that we've used on it. We can look at the labour and also look at productivity as well. One of the things we were blind to starting this originally was looking at the productivity around how fast can you go, what is it you can actually repair in a single shift. And then longer term, having captured all of that, we create a health and safety file, and that then feeds back into our other databases within National Highways, and also allows the national team and the regional teams to see what it is we've actually repaired and have that record, if you like, associated with that strip of road, which is something quite difficult to do at the moment within National Highways using traditional methods. Overall then, we come into the portal, and on the portal you can see all the little blue dot. This is where the concrete roads are that we've surveyed in the RIS2 period, and it gives us a chance to have a look at that digitally about how we look at things. So that means that as a network as a whole, we can, for the first time, tell you where the defects are and what type of defects are the predominant on the network. So this was a big shock to us to find that spalling, for instance, is the biggest defect. We always thought it was cracking was the major defect, but when you look at spalling, that means that we should be looking at better repairs, better designs for when we do things with materials to repair that type of defect on the network. The other thing it also shows you at the top of the slide here, the Spooner Road to Tuttles, is this is a fail pavement. This has 73,000 defects on the pavement, which are significant. So it kind of gives you an idea about the type of pavement we are still having to manage and make safe for the public to travel on before we can reconstruct it. And we'll be going to reconstruction on that pavement early next year now, but in the interim, we've spent in the region of about 2.5 million this year alone in order to keep the roads safe for the travelling public. So when we have a lot of defects on a particular road section, it means we start to spend a lot of money quite quickly just to hold it and keep it safe until we can get to reconstruction, which is our preferred state of for the roads. Each of the survey points on a driven survey is in a blue dot, and we can pull up here all the information about that, what that piece of survey shows you in terms of what's in the road. We can look 360, we can look down at the pavement. We can also look at things to do with things like power lines. This is crossing a river, for instance, so we can look at the bridge structure associated with it. We could also look at things like environmental concerns. We can map those out in the mapping so that we've got a full picture when we go to the road about what it is we need to be aware of on that kind of basis. This is a photograph of the digital map we work in. So from here, you can see it's very nice and clear. We can, using the digital map, mark out, or we can superimpose the photograph over the top, knowing that we can actually work in the digital points. So wherever we work in that in terms of measurement, we're 2 centimeters accurate in terms of that. Prior to this, we'd have a strip map on a spreadsheet, and we'd be working probably as best we could to about 1 to 5 meters of accuracy on the road, which is quite a significant difference in terms of trying to find things to look at when you're looking for defects. The end-to-end digital also allows us to capture information, and we can offset that. So the person on the side here on the lay-by, it means that if we see something further out in lane 1 or 2, we don't have to close the road. We can actually move the cursor over the top and describe the defect we're seeing, if you like, and then record it on that for that purposes for the scheme moving forward then. This is what the end-to-end digital map looks like. This shows you, if you like, the layout of the road and all the different bits and pieces associated with it. Sort of flashing there. We'll move on. Oh. Okay. The other thing we've also been able to do is switch this into white ortho, which means that we can flip the map, if you like, from the digital image you just saw previously to look at the gradients on the road. This is on an asphalt road and coming around a merge. So the road over here is merging into this main line here. And one of the things we're looking for is flooding hotspots, so that when we relay the surface of asphalt here, we can actually take the flooding hotspots out. So for instance, where we've got seam joints, where we've got a previous repair, all of that has the potential to hold up water. So it's possibly only 2 to 3 millimeters deep, but that potentially creates a problem for car tires traveling it in the wet. So we can then, when we do relay a surface or reprofile the concrete, we can actually take out the flooding hotspots or the areas where water is gathering on the network and not getting away. So the AI, what does it see? So these are the defects it actually picks up. This is actually on the A11 Spooner Road to Tuttles, which I said was one of the worst bits of road, but that just gives you an idea about the sheer quantity of defects on our worst roads in terms of all the different cracks, all the different problems we have associated with it. Hopefully that will come up. Yeah. So what that gets us to then is a map in the end, which is where we want to do the repairs on the road, where we want to take out and repair various cracks. Originally, when we did this, we were about 65% accurate. We're now to a state where we're about 90 to 95% accurate in picking up all the repairs on that basis then, so that we can be fairly certain that what the AI sees is what we would want to repair as engineers. And therefore, it takes us a lot less time just to do a cursory check over and make sure the repairs align with our repair strategy. So that concludes the work we're doing currently in the Centre of Excellence. It's a vast portfolio. It has a range that stretches all over the place on that basis, but it needs to in order to be able to help the concrete road program, if you like, move forward in an intelligent way. What do you say the benefits are? Well, originally we had a budget of 500 million for this RIS period. We've managed to save already 104 million as pre-efficiency just by creating the concrete roads framework and program. And we'll probably attain another 30 to 40 million in efficiencies by the time we finish the RIS period in 2025. So that shows you that thinking ahead, being innovative, actually saves us program money as we move forward and looking at innovation. So as I've got a few minutes left before I hand over to Peru, are there any questions you'd like to ask me?
We have a question from the chat.
Yeah, I was wondering.
So the question is, could you please provide some details about how you are recycling concrete for the possible application in road projects? And is there any pre-processing before you use recycled concrete in a new road project?
So yes, we've got some details coming up. We've just started to look at the schemes that are going to be the main recycling schemes are starting next year, but we've already started to plan ahead for that. We've looked at different ways of breaking up concrete. We've been looking at a technique from Holland at the moment in the States, which is a low amplitude breaker. The traditional breakers are quite hard on the foundation below. The new low amplitude breaker is actually quieter in use. It actually only fractures the concrete, which means a lot of the base, if we want to use it for the build up of the new road above it, remains intact and creates a good base to build up from. It also means that the vibration associated with the traditional breakers isn't present when we use this new one. So typically the reason for that, we're looking at that, is because a lot of our roads are within 50 to 100 meters of existing buildings. So from our perspective, where we go through an urban area or semi-urban area, we're looking to try and protect. What we're looking to do increasingly is recycle on site. So basically, to keep the carbon footprint down, is to initially break up the concrete into usable chunks, screen it, if necessary, wash it, and then put it into a stockpile. So once we've done the initial excavation, we can bring it back. So what we're looking for is any journey greater than 45 miles creates a carbon footprint for us. So what we're looking to do is try and keep the carbon footprint to within 20 miles of the actual site when we do the breakup. One of the other things we've been looking at as well, although we've not quite fully resolved it, is where we do life extension works and we're just pulling up 2 slabs on an evening. What do we do with that concrete? How do we reuse it? So at the moment, we take it to certain recycling centres and make sure that that is recycled back into building materials for the, if not the road or pavement to use, to go back into other sites like base foundations for buildings, etc. On that basis, so that we can show that we've taken our pavement and can create a carbon certified trail, if you like, to ensure that we've had best use from it on that basis going forward. But there's a few bits we want to do with that to improve that further. We have been thinking, where we have a lot of schemes in the East region, we could actually collect all of that together. There is a cost in doing that in terms of storage and transport, but where we have schemes literally 5 miles down the road that will need quite a lot of material, is whether we can actually then reuse that material either in operations or in major projects to use this base material in other pavements as we move forward. It's just a question of thinking about the costs associated with that. We can do most things in terms of recycling concrete, but the cost is one of the things. You don't necessarily want to pay a high cost just because you can recycle it one way, if you like, when there might be other more beneficial ways. We've looked at, for instance, taking some of the concrete off for paving slabs, and we've been talking to marshals, for instance, to reduce the loss of the decorative paving slabs in the country. We've also looked at with Stanton Precast up in Derbyshire, for instance, if we can get a load of concrete to a railhead, we can actually deliver that to site for them in Derbyshire at very cost-effective, low carbon footprint. Then that means that we can then create drainage or other products of precast concrete for the network as a whole. So it was still exploring this. Any of the reports we've done, you can have access to. If you just email me, my email address is on the slides, and those should be able to be shared with you today. Please contact me. We'll quite happily show you all the different reports we've been working on at the current time. And as we get new ones, then you'll get a link sent to you, if you like, with the latest reports on what we've been working on.
Thank you.
Yeah.
Hi, Michael. I think it was a very nice presentation. You briefly mentioned that if you look at where the CO2 is going, that 80% comes from the diversion of traffic while we were executing works on the roads. Do you have an idea of the global distribution, the pie chart, so to speak, of the CO2 emissions?
The answer to that is not yet. We've literally just found that is one of our key factors this year. So we're starting to look at how can we either reduce the diversion routes or do stuff on the network. Traditionally, if we do life extension works, we'd have gone on at night time with low traffic flows and not put contraflow on because it creates a disruption to the network. So typically you might be sat in a contraflow waiting to get through the contraflow past the works for 20 minutes. That in itself, stacking traffic creates pollution. So we're trying to look at how we do that effectively. One of the things that contraflow on the network does is allow us to work 24/7. And where we did it on the A14 in January this year, we actually saved 48 nights of work, if you like, where we would close the network traditionally. So roughly a month and a half, we actually managed to do all of that work by doing contraflow on the network, despite the congestion, in 2 weeks. So that's one of the big savings from that. So we need to think differently. Phil suggested earlier that we think differently about how we do the delivery side. And so we're just starting to look at that now about how we do the delivery. What is it we can do faster and quicker? Do we need new machines? We've been looking at different types of machines to do plane out, to do fracturing of the concrete, if you like, and lift out. So we're now using things like vacuum suckers because they use less energy, for instance, than the traditional saw cut and break up using a breaker, because we can then basically cut the slab in quarters and lift it with the vacuum onto a truck, and that's straight down the road. So we spend less time, less fuel, if you like, doing that technique on that basis. So I think whilst we're looking at the diversions, it's every little thing counts. But we are looking particularly at how we might go about using network closures. One of the big things we did in 2020 was use a lot of the time that we had available with the low traffic flows due to COVID-19 and lockdown to get in and do some particularly problematical sections. So again, we're thinking ahead and thinking, are there better times of the year to go and do things where traditionally we couldn't do before? And one of the things that associated with that is finding concrete repair materials. For instance, winter travel tends to be less, but then we're operating at -5 or -10 centigrade on the network, and trying to get the concrete to set before we reopen the next day. So we've actually found a few materials now that allow us to go down to much lower temperatures in terms of road working, and allow us to assure that we can reopen the road the next day as well.
Okay, thank you very much.